Today I'm going to talk about wind energy as a supplement to concentrated energies for generating electricity. Wind energy has enthusiastic public support. People like it, and so do the politicians. The concept that wind is free has an irresistible appeal. But wind only provides electricity, and only sometimes. And electricity is very important to us. It's the key to modern society. If electricity stops, everything stops. Electricity provides energy for all the machinery and equipment in our offices and factories, and it's the backbone for our communication systems and our control systems. And when the electricity stops, all these things stop. And there are no substitutes for electricity, not on the scale required. And so we use stored concentrated energy as coal and uranium to provide electricity because we need strong, reliable electricity to run our systems. 200 years ago, the main power for ships was wind power, and ships were small. There were very erratic arrival and delivery times because nothing could be scheduled. Then the steam engine was invented about 200 years ago, and then we went to concentrated energies, wood, coal, oil, and now uranium. And so now we have large, fast ships on reliable schedules, and that's the benefit for everybody. We now have reliable schedules for deliveries of food and things from many countries. Now, why are we trying to generate electricity by wind when electricity is so important to us? Well, there are four illusions that people have. One is that wind electricity can provide electricity for 100,000 homes. The reality, wind cannot provide electricity for even one home unless it has a support system. Okay? And it requires concentrated energy support. And why is that? Because that's what wind energy looks like. There's the delivery of wind energy in Germany in 2004. And you can see there are many times when wind is not delivering, or it's delivering very, very much, and then it drops off quickly. And these little points here where it's not delivering are not trivial. In February 2003, in the West Denmark wind farm, delivered no electricity for a whole week. For a whole week, no electricity, okay? So these things are not trivial. The second illusion is that the wind is always blowing somewhere, and so that with the implication is we can just plug in and we always have wind. Unfortunately, it's not close enough usually. Very large areas act as one wind farm. Ontario acts as one wind farm, and that was in a paper that was printed in CCTC 2009. Okay? And Ontario is 10% the size of Canada, which is the size of Europe. And Eastern Australia is geographically the largest dispersed wind farm system in the world. And in 2010, it produced less than 2% of installed capacity 109 times for 5 to 70 minutes. So that's not very reliable. The third illusion is that wind is green and clean. And it's not either if you're going to maintain constant electricity flow with fluctuating wind. The support fuel is coal, oil, and natural gas for the world. That's the worldwide. Occasionally there's places where you can use hydro to support it. And this is an hour-by-hour chart in Denmark in 2002. It's another chart which shows you the variability of wind and how everything's up and down all the time. Wind cannot stand alone. You can't just have wind. You don't want wind power just to supply your house, because you want power when you need it, especially if you're heating your house with electricity. In the wintertime, you want electricity when you want it. So every electricity system has a support system. Now, the support system is large enough to carry the complete load because sometimes the wind is zero. So what really happens is when you have a kilowatt of wind power coming in, this flow from here drops by 1 kilowatt. And so the savings is the cost of the fuel to generate 1 kilowatt of electricity. So the value or the worth of wind electricity is the worth of the fuel displaced. If we run wind power, the average wind power at 20% capacity factor reduces the fuel from that system I just showed you by 14%. If the capacity factor is 35%, it's 25%. So the reduction in carbon emissions from a coal plant is 14 to 25%, depending on the capacity factor of the wind plant. Now, if the amount of wind increases, we can increase it right down to zero, then the coal-fired plant still has to run because it has a lot of inertia. You can't cool it down and start up very quickly. So if this goes to zero, then the coal plant runs in spinning reserve mode. It burns coal, it keeps the steam pressure up so it's ready to react immediately when the wind stops, but it never stops completely. And another thing that happened is that as the wind increases, the grid reliability drops off. The very best application for wind energy is where you have diesel engines and you're up in the far north where the cost of diesel fuel per kilowatt hour is higher than that for wind. So the diesel engine can follow the load and it can go into idle with very low energy consumption, and it can follow the wind, and that will pay off. That's where the cost of diesel fuel is higher than that for wind. Now, the fourth illusion is that wind power is free. That was the original concept. People like that, it's free. But all energy is free. Coal, oil, gas, uranium, wood, switchgrass, they're all free until you have to start to use them, and then that's where the cost comes in. Wind is very costly because it's dilute, very dilute. It's usually remote as well. And so maybe you get 1 watt per square meter of energy out of it. Whereas with coal, it's 200 to 800 watts per square meter, and for uranium, it's 80 to 800 watts. So they're much more concentrated. Now, wind is often remote, has long transmission lines, and the turbines are exposed to weather. Now, when you contrast that with concentrated energies, the actual generation is enclosed, it's protected from the weather. You can put the concentrated energy wherever you want. It's easier to move concentrated energy than electricity. So you put the generation where you want it. It's close to the source. Transmission lines are short. And one of the other things, we talk about costs and so on, but just talk about copper, for example. To a wind farm takes much more copper than a concentrated energy system. There's more copper to collect the electricity. Now, let's talk about the value of wind electricity for various sources of fuel. Steam coal in the U.S. costs $20 to $100 a ton, which is 1 to 5 cents a kilowatt hour. For oil, it's very high, like 15 cents a kilowatt hour. Gas at its current price of $3.30 per 1,000 cubic feet is 3.3 cents per kilowatt hour. Hydro at zero. Wind and water are free, so there's no economic advantage for doing that. Gas turbines are about the same as steam electric systems. A combined cycle system is much more efficient, so the cost is lower, but they're not flexible enough to handle wind power at all. And then the last one is nuclear at 0.5 cents a kilowatt hour. Now, if we look at this, all the fossil fuel costs here are subject to wide fluctuations. As fossil fuels become scarce, those are going to go up. So there's no price stability for those. But there's price stability for hydro and for nuclear. So in the long run, those are going to be the ones that are price stable and the ones that are going to be most valuable to us. Now, even if the price of uranium triples, that only goes to 1 cent a kilowatt hour. So that's price stability. Now, what do we pay for wind power? In Germany, EON nets is paid 10.4 to 14 cents per kilowatt hour. Plus, there's another cost for the spinning reserve fuel, which is not included in here. In Hydro-Quebec, we're paying 7 cents. Now they're paying up to 10.5 and sometimes 14. Ontario has some project at 11, but they're now paying 14 cents. And in the U.S., it's 7% plus. There's this plus other state and federal taxes. So that's what. So we pay 7 to 14 cents a kilowatt hour for wind. Now, when we talk about wind power, we also have to talk about safety, as we have to talk about every source of energy. So wind power, as 0.17 fatalities. Natural gas is this, and nuclear is much lower. So nuclear energy has the safest record of any energy for producing the large quantities of energies that we want. Now, those turbines look like they turn very slow, but the tip speeds are up to 300 kilometers an hour, and that's 3 times faster than you drive your car. And you know how insects spread across the windshield of your car? Well, they also spread across the turbine blades. And they act just like frost on the wing of an airplane. And airplanes won't fly with frost on their wings. And when you get insects on a turbine blade, the power level drops. Okay? This is something that happens. Now, they also kill eagles and geese and bats. Some people say, well, cats kill more birds than wind turbines, but eagles eat cats. Okay. Now, during icing conditions, wind turbines throw chunks of ice. I mean, this is well known, and big chunks. I've seen pictures of big chunks of ice thrown off, and some people have been asked to leave the wind farm because it's icing conditions. So wind energy is hazardous to humans and to avian life more than other forms of, such as nuclear energy. So in conclusion, summary conclusions, wind is very popular with politicians. Some politicians have told me we put wind farms here because that's the only way we can get work into that area. Shipping abandoned wind 200 years ago because it just didn't work too well. And why do we apply wind to electricity generation? Because electricity is so important because of these 4 illusions. Wind can, X number of homes, it's always blowing somewhere, it's green and it's free. And the value today is 1 to 5 cents a kilowatt hour, and we pay 7 to 14 cents. So the conclusion is there's little, if any, justification for supplementing concentrated energies with wind energy. So that's my message today. And Andy says we'll ask questions later.